this reply. I'm not sure how to play this. I didn't finish reading it, but I wanted to. I want to sort of do this differently, so to remove bias from you guys. I already know the source, so I'll reveal it. I'm just creeping up slowly to the top because I want you guys to read it, and then maybe I'll do the reveal. I have not read it. I only read the first paragraph, I think, and I said, let me do this kind of live with you, like I like doing with you guys. Let's see if I can hear the mic. A little more. I'm creeping up. I see it on my cell phone, so I'm at the desktop now. Okay. All right. First, all technical statements are mine, not the students who conducted the analysis using previously validated methods. This is my work, and findings are mine alone. My students had the modeling expertise, but, as you rightfully point out, do not have the expertise to provide insight into the collapse. I welcome conductive technical support criticism of my work. Happy to discuss the technical aspects of the investigations. However, the analyses that were conducted cost less than 20 grand and were done in less than 2 months. This was not about money. Note the final conclusion will be provided by NIST extensive team. Okay, so of course I'm on my triggers now. As you read stuff and as you get things, the amygdala, the psychology of it, the triggers. So this person says the final conclusion will be. I'm going to title it. The title is going to give away where we're going. Let's just reveal. All right. Thank you for making this, Dawn Lehman. So you guys are getting it as I'm getting it, and let's read. I had not seen it before. This video, I believe she's talking about. I just wanted to jump on here to try to clarify my approach. Yes, clearly I'm a bit late to this, but I still believe some of this is relevant. Okay, so this is 22 minutes ago. It is 23rd September. So this is also an older video of mine, and Dawn Lehman is making a response to it. And clearly she can have different positions as we grow. So that's clearly not a fight from me. I agree. You can change your position. And that's all I'm about, is that for intelligence, for people to be intelligent, I watched somebody do something on YouTube, and they're talking about how to grade intelligence, how to grade it was the Donner effect, the effect where you think you're smart, but you find out you're not smart in something, and then you drop to the bottom, and then you come back. Maybe you come back to realize, oh shit, this is what I need to know, what I need to learn. Well, I don't want to give credit to the guys because this has been around way before that guy. Those two guys came up with it. But that's why I don't want to say the second part. If you guys know, you know. And so intelligence, in my opinion, is someone that anyone that can learn, period. That you can learn from your mistakes, that you can learn from other people's mistakes. And so this missed video, I have not reopened it. Maybe it's got tons of mistakes that I could edit better with hindsight and new knowledge, new information. Now that we know about the cracked planter boxes, for example, 2 weeks out, maybe this clearly would have added that detail had I known it. Not clearly, I don't know what I would have done. Okay, so the person, Dawn Lehman, says, I welcome conductive technical support. So this is her response so far is disarming, which you want to do. You don't want to come at it aggressive yet. Maybe you'll get to the bottom and it can be aggressive. I don't know, but this is disarming. This is the way you de-escalate. And anyone saw the video, I revealed that it wasn't quite de-escalating. She was quite triggered, and I triggered back with the Twitter stuff. Doesn't mean I have to hold my ground. I don't have to die there, guys. So she know. I don't die there. If Dawn Lehman is just, I'll post this video. If I think it's worthy of further communication, then I'll go further communication. I don't throw out the baby with the bathwater, all right? I may dislike NIST, but NIST may have some data that presents to us. I may dislike, biasly so, some of the people they chose to be part of this investigation. Oddly enough, since Dawn Lehman has published a few things, she should be part of the investigation as far as at least someone that can shoot things off their, they can engage in it. Engage and say, now, what do you think of this data? What would your conclusion be now? Just because you throw it at them, you throw it to see, maybe you can find a defect in our thinking, and we'll fix that defect and we'll publish then. But NIST is going to publish without ever allowing people to first, debunk some of the things, and they go, you know what? Here's a rebuttal, and we're going to now adjust our position. But you don't want someone that's going to have a position that just holds to it, digs their heels in, and says, that's it, I'm not moving off of it. For example, my vibration that didn't cause the building collapse. I sort of dug my heels on that. So I would be a good person to help debunk you if you come up with it's only vibration. But I wouldn't be a good person to support you unless I go to debunk you and your data shows that, wow, I didn't know that. They had photographs before and after of all the cracks, and there we go. And then I would clearly have to say cracks, vibration was participated. And maybe even was a cause if you had photographs that can show before and after. Okay. Happy to discuss the technical aspects of the investigation. However, the analysis that were conducted cost less than $20K. All right, you put a value on it. All right, right, and says NIST is going to be the person that she's going to allow to be the final decision maker. I have provided that some understanding of my understanding of what might, capital letters. That's how I talk too. So some of you guys hate that I use capitals. She used it too. Have initiated the collapse sequence. I was not predicting the overall collapse mechanism, although you can see that different theories are discussed. I will say that I believe that the wall to slab connection is one of the weakest that led to the wall to slab. So wall to slab. I think we're back at the so just so you guys know, I'm being soft. This is not going to be a punching video. When she comes in her comments like this, I don't punch. I dial that shit back. I'm not one to kick at this point. We're communicating. So the wall to slab connection, I believe she's talking about internal to the building over there. The shear wall that stayed. The building, the primary building that stayed. Primary building. The building that didn't collapse. Didn't, fully collapse. That wall there by the planter box. I don't think she's talking about the south wall. Incidentally, I think their program is pretty, the program, when I said that in a video, and I don't know, Dawn Lehman, since you're watching this content, I don't know if I got shadow banned. I was in the tens of thousands of views, and then went to right down the hill because I revealed NIST, showing the destroying evidence. The disposing of evidence, destroying evidence, displacing evidence, if you want to say it nice. Your computer program, I thought, and again, the video is there somewhere. I don't know where it is now, but I thought your computer program, for what you programmed in it, it actually revealed, I thought, pretty damn good, in the color variations, not where not where you were inside the room of the gym, but forward to that, there's the crack outside that planter box that I show in a video that was before the building collapsed. And that stress looks like it could correlate to one of your like number one, where you are inside there, number one, the main building. If only you could push that forward, it would have revealed the crack that I revealed. It would have been in line with that. So that would be biased, but I was looking for that program to reveal the cracks to superimpose the cracks that I know of. Now, interesting, could it superimpose the crack by the planter box, going back and taking another bite at it, looking at your drawings? Can it, your computer program, can it show the cracks that the lady, I believe it's a lady, that came 2 weeks before the failure and show the planter box rotating? Will it show between what I call the butterfly down the middle, the butterfly collapse area, the one that goes down the middle, the one that's where the cars, between the cars, it's a continuous butterfly. And I'll reveal now, talking to Dawn Lehman and the rest of you guys, Look at the railings. I've been holding this out for a while, but I've hinted to it many times. I say, look at the planter box, how the planter box is like a strong back. Look at the railings of the planter box. They're not bent. All right, they're not deviated. If you look at any collapse where, use the one in Germany just now. Norway. The bridge collapse. You can see the deviation of the railing where it shows the fracture, where they both folded over, if you will. The railing reveals the fold. If we look at the railings at this deck, left and right, yes, the planter box appeared to be presented on top of the deck, and they could float, if you will, but they wouldn't typically not float. The strong back effect wouldn't work unless it went down together. Let's move on, which means the butterfly in the middle started, is my starting point. With the fractures also by that column, by the planter box that's over there, by the one that stays on the shelf, the one that's still there that talks about my cantilever effect. Okay, 20 grand, right. This was about doing, okay, so my bias against Dawn Lehman was obviously the Twitter thing, but also the money-making thing. That was just biasly put out there. And I stated it was a bias, but, I'm willing to retract it, even delete the video if it's harmful, because Dawn Lehman's open for discussion, and I'm not. And I've always said it. I challenge anyone and to come and talk to me about it, the engineers there. And now Dawn Lehman does it. So, yes, I will not be a puncher at this point. I don't do that. It's not the way I'm built. It's just a normal conversation. This was about doing my best with the information I had to provide some understanding of what might have initiated the collapse sequence. I was not predicting the overall collapse mechanism, although you can see the different theories are discussed. I'm obviously going over the paragraph again. I will say that I believe that the wall to the slab connection and one of the weaknesses that led to the collapse. For you guys who don't know, I have LASIK, and sometimes my vision goes in and out. And so that's what that was. I wasn't trying to analyze the words or misread them. I was just letting my vision catch up, which it's still doing. Lead to the collapse of the eastern section of the building. It's like blurry right now, but other engineers and it's LASIK for you. They take your eyes right out sometimes, and you just need a rest, whether I like it or not. Engineers who were interviewed had other hypotheses. Okay. I will say this is a true statement, obviously. I will say that to date, this is the only nonlinear analysis of any portion of the building that I am aware of. Yeah. But I'm interested in other investigations if you know of any. Okay, that's kind of a loaded thing. No one else is stepping on it. Yeah. So you know what? She gets an A for that. Oh, wait a minute. No. Correction. A couple of people came after you. There was one guy, something, I'll say his name, Days or something. But he left off the entire south wall when he ran it through his program. He's young, he's new. Now he's a year older and his maturity, and he's left this topic alone. But I beat his video up because he did his analysis and he left the entire south wall out of his drawings, disconnected, and he says he's an expert for quartz. There was another guy, I don't understand, in Mexico. Somebody sent me his links. He did a book already. And then there was another guy who said he ran analysis. Let me think. My brain's trying to, I'm a very photographic type memory person, so I see the guy, but I'm trying to see his video of his, if he ran any finite element programs on it. Wow, I'm getting blocked with that. I keep my brain wants to say he did it, but I can't see his video. I can't see it. It's odd. I'm flashing back to them beating him up on that forum over there on Engine Tips. They beat him up and he disappeared. He was like, you know what? All I was doing was pointing out some errors, and it was Josh's videos, and they attacked the hell out of him, being pro-Josh guy, instead of just letting him, challenging him for what he stated. Okay, let's move on. So that wasn't, no, you did the deepest, all right? So you did the deepest, period. I just had an agenda that, or bias that you were making money on it, profiteering, and then, of course, because of the Twitter thing, and your statement saying you can't analyze a structure and its failure state, that made a bias against me, against you. Now, talking to you, I'm able to put realize I have a bias and let people know I always told them it was a bias, and go from here. I've made close to 20 presentations on the structural engineering investigation, which is not presented in any articles. Okay. I use 4 primary sources of information. Okay. Timeline of eyewitness testimony and survivor. No one living in the 10 stack survived the collapse where residents, and the 11 stack did not. Note, no one living in the 10 stack survived the collapse where residents in the 10. Okay, no one living in the 10 stack. That she didn't interview people they're still alive, and the people that died, she obviously didn't interview them. Dawn Lehman, if you get this, I'm going to reach out to you and give you some non-disclosable information. 11 stack did. 2, images of the damaged, collapse, and undamaged regions of the level. Okay, so further, the data she used. Images of the damaged, collapsed, and undamaged regions of the level 1 slab. Undamaged also. And I think Dawn Lehman might have more data, images per having access to the Miami Herald. I have bias on Miami Herald with a few things, but they released the data, so I don't have bias against anybody releasing data. I mean the data. No hate there. Sorry, there was something in the background. Columns, walls. Okay. 3, structural drawings. And 4, structural drawings. And 4, my knowledge of connections and member failures from my research. I used the information to evaluate every model we tried. There is a lot to say. My presentations are between 60 and 90 minutes, but I did want to point out a few things here per this. There is a video providing fracturing reinforcement. There is a video providing fracturing reinforcement bar sounds, forms, or labs. And okay, so Dawn Lehman, I think I trolled you on that one, or trolled your content on that. There is actually a video of the sounds. If you go of the literal sounds of the structure. If you go to the ring camera, it has it. That's the video I did that, saying you need to look no further. I don't even know if it's in the video you're commenting on now. This one, I didn't review it. So there is one literal of this one. If you want to hear the real sounds of it. The building going down, you also hear it. And the audio of the lady with the ring camera. The internet phone, the phone when she calls in, we hear it go down. A couple of them. I'm not sure how, we do hear a couple of cracks, loud snaps, but we're assuming that those might be of a steel nature, right? The pops you hear of a steel nature. There, I would say acute fractures, something acute happening. It comes to rest. If you listen to his ring camera, it comes to rest. And then it starts again starting of that is the loud snap. That is the ring camera's interpretation of a noise, of a sound, of a noise, of a sound. Sound is what we hear. The noise is what is made. Yeah, are they both the same? That's kind of semantics. Let me move on. So I am not saying that this is what they heard in terms of boom, boom, but it is one possibility. I get his data, and sometimes we get aha moments like, oh, I think this is going to be great. And then later, I've done quite a few of these, and later you're like, I'm not sure if I read too much into X. Maybe I shouldn't have read that much into X. Dawn Lehman, if you look at the roof, since you've looked at the structural plans, it's overlooked. I haven't seen anybody publish this. Remember, we have the conflict of something buckling down low around in, let's call it, one of the area there because of the way it piles down in there. But we also have the roof starting in the video left. So we got two movements. And how do you go from the ground floor basically to the top floor failure? I use the outside columns being they only have four structural steel members connecting the slabs, the plate slab system, and also the top floors being of weaker, if you will, connections. I do a lot of concrete pull-out tests, rebar pull-out tests, and it's a huge difference on a concrete that really has a strong strength. And I'm being purposely leaving Olay not high concrete content because that doesn't make it strong and pull out. It's the interlock, how everything interlocks. The rebar at the top there was down to what, 6,000 psi, 4,000, down from 8 on the lower level. And then we have reports that this, I got to be careful here. Someone wants to partner with me with something, and I'll just say that the drilling, confirming the drilling of what the demo guy said, it was very soft. Yes, that was confirmed by another contractor who got hold of me, saying that concrete was, soft. It was not troublesome at all, and we're talking at the 8,000 psi required level. How about that? And well, concrete crush tests will be nice to know, but pull-out tests are more indicating of bond strength and how the concrete behaves, more so than a concrete crush test. The compression test, right? So then at the top there, go back to there and you'll look in the reports, you'll find that they did, and I don't want to dive into it with this, they did do a repair on the roof, a major structural repair that I did a video last week calling vectors of repairs. Repairs, you get all right, so I've done quite a few testing. Let's just say we have a slab. I'll take the slab, I'll bond it together with epoxy. A lot of people bond cracks with epoxy, and they say that's it. Then I load the slab again after the epoxy is matured. I load it, and the fracture moves right to next to the epoxy. It doesn't go back to the same crack spot. It moves over. It just moves over. All you did was shift it over. Now the break will be, if it's a little V, so I'd have to link the video, but I did one. But imagine a triangle, and that's the section that's missing. I epoxy both sides of it. I load it. The triangle's fair game. It's just going to move one side to the epoxy. It's where when you load it, it's going to fail one side next to the epoxy still. The vector's still there. It didn't change. Except for if you make it too rigid, which I call, if you look at my videos, concrete staple. Yeah, the low-tech videos, but it so contractors can understand it. So I show the staple and how the staple directs the forces out to back in compression, but using a staple effect. I'm losing it. Let me get back to this. I'm going too far away. I'm just stating that, or trying to state that repair on the roof, and the repair on the roof is an explanation on why, once the building rattled, why the face would have broken free, especially at the top floor, with the repair being rigid. And so it was a structural repair, huge structural repair, and that shows the roof was failing, and so that gives us our roof. But it's not the beginning. I don't think it initiated the collapse. It might have, as the first part buckled and the video takes on. So the delay in the video, I believe it's a motion sensor camera possibly, or they have a full video of it that the motion sensor picks up, and then that's what it picks up at after the motion already started. Oh, I just picked up somebody else's personality with it. It's the way I learned, guys. Sorry. It's how I can adapt, chameleon style. We were similar, possibly. Okay. What I did was to conduct an initial, not definitive, not comprehensive, just initial investigation into what damage in the pool deck could result in damage to the tower. We were... Okay, so I simply call it deck ledger failure. Simply, just like a wooden deck, it falls away from the building, but in this case, it tugs on the building, and we start getting this rattle effect. Quite some time goes by, phone calls are made, and we are where we are. Phone calls are made during that, before the building It was still not in equilibrium. It was, well, everything's in equilibrium. Even while it's collapsing, it's still maintaining equilibrium until it finally comes to rest. So when the phone calls are made from Cassandra Billadu Stratton, for example, that's a timeline of how much time they really had making doing the communications. We were simulating possible damage mechanisms leading to collapse to the tower. We did not simulate the full building. Yeah, I've played around with entering the building a few times and having the collapse work up. I have it, but I have to do 2 positions. Remember, I believe it's lower building and roof deck, per the video. Roof also. But I'm sorry, when I say roof, I really mean not the top floor. I'm thinking more like buckling in the floor below. Although I just mentioned the roof repair, but I don't believe that was the. There's another. They put another. They did. You know what? I'm not there. Let me move on. I can see why this was confusing with the statement in the video. We only simulated level 1 and the supporting structure. I'm going to have to look at the video now. The images included in this article were determined by the Miami Herald team. The images included in this article were determined by the Miami Herald. Okay, so they determined it. Okay. If you are interested in the simulation, I would recommend reading the article on the LS. Okay, the peer review methods were published. And, well, you're working back on my bias again. I don't like your peer review, the peer review people. I did look at that. This refers to the modeling approach, including information about the constructive models, connections, bond, and the elemental formations. I saw where your peer review came from. Sorry, I was biased against it. That's okay. Cell phone. Of course, this article in the Miami Herald did not go through formal peer review. But but you know what? I'm biased against this peer review thing again, because NIST is going to be, like you said, the ultimate statement on this whole thing. And then anybody doing it now has got to put themselves up against peer review against this article I call it, published by the people that destroyed evidence. To be clear about destroying of evidence, the person that I took the video from, that I got the content from, they showed up at his house, the police did, and told him to stop filming. That's how much they didn't want. And they were monitoring it live. And within 24 hours after that, my channel got dived. You couldn't find my content in a Google search anymore. But if you watch the video, you couldn't find it in a typical Google search. You got to search by day or channel. But if you watch the video, you can see that there are specific failure modes that are attributed to me. Okay? Primarily the failure mode in the pool deck region, all right? And other failure modes that are attributed to the other structural engineers who were interviewed. Yes, the analysis is my work, but this article was not written by me, and the Miami Herald consulted many other engineers. As they said, just want to make sure that you are only attributing my work and my statements to me. Specifically, I did not suggest that the columns buckled. We did not simulate that failure model. So I would not state that. So if I stated that, I retracted them, but she said she didn't state it, then I retract it. I do not believe that I took liberties, but happy to discuss that as well. Okay, there are many theories. I take liberties. I don't mind taking liberties, but I'll let you guys know when I'm taking a liberty. I'm taking a little liberty here, meaning, I might be reaching, but let's do it. That's what theories are about. My theories have always been focused on the progression of the collapse in the pool deck. Okay. A few additional notes. I also point out the damaged slab around the planter box, which might have supported a theory that the planter stiffened the slab and therefore might arrest cracks going into the structure. All right, so we're talking about the planter blocks at the structure now. Good eyes on that one. I have one photo that shows the planter box you point out is intact. Okay, so how could the damage propagate into the building, though? The 11 stack? Oh yeah, well this is the thing, isn't it? I've got two of them, and they're coming towards your back towards All right, it's definitely coming from the crack that's there, Dawn Lehman, but I think it misses your gym area. And I know the computer software can start making a bias in you once you see it, and you go, okay, confirmation bias. At that point, you're like, let me look over here. All right, it's saying over here, I see the data's pointing there. But I think the computer program, you need to be able to put in, all right, let's take away a value here. We have failure here with this crack, all right? Cracks are a failure or great stress over there. Yeah, so I'm going to edit that a little bit. It's a stress indicator of the deck deflection when you see a crack. It's not necessarily a failure. It could actually be engaging the steel to functioning. Then we have the fractured core samples by the car area, which shows that steel is not engaging. And it only has, and that's right there before it connects from the slab. Yes, the elevation change into the main building, and it's not connecting. It's not connecting there. And then we have the fracture of all things. I always say biasly, that engineer that did the core sample over by the planter box, he's not letting on to what I guess we won't know right now, to what he knew. Because why did he sample there? Why did he sample there? Would you have sampled there? I've seen many a damaged structure, and I can't think of why just somebody off the cuff would say, hey, give me a core sample here. If you look at his reports, he had limited budget to sample. And he chose exactly where another core sample shows not connecting. And it was at a transition again, Dawn Lehman. All right, so I called you Dawn Lehman. I'll call you Professor Lehman. So the transition, because I think it was a bias calling you Dawn there for a second. I think I would have called somebody else Professor. So the core sample there is also at a transition. So this, I'm getting feedback from my mic. Let me dial something down there. Hopefully you can hear it, but I can't tell if I'm talking too loud. He also picked the transition where it's a transition to a new elevation, and that would be, 7 inches on the first slab, and then 11 on the second one. He also picked a core sample there, and he did not pick it anywhere else that was in his collapse zone. He picked out further. Then he asked for more money to do more core samples, and he went outside the building. He went out to the other end of the building and did the over the little planter box area with no cars. He didn't. I would think that came back weird, like 6-inch depth or something, or 8-inch depth. That was a weird one. All right. I also point out I don't know why I remember 6. It can't be 6. I'm remembering 6 for something. A few additional notes. Okay. I never have suggested that the beam brought the building down. The beams brought the building down. Okay. If I stated that, then I'll have to review that again to state why I would accuse you of saying that. Or maybe you're just saying you never said it. Again, I didn't really look at the video. I'm replying to your comments. I'm not sure where I referred to columns. Okay, I'm not sure either right now. It was that video there. I do recognize, however, that the engineers have referred to these columns. See the New York Times and the WP articles. But the New York Times, I see you doing triangulation, it's called, right? You're trying to send me to look here and here for supporting statements and also to deflect a little bit. So that's my bias, and I'm not sure of the data behind the New York Times, where they got their source to direct themselves to say columns. All right, so I have never said that the slab pulled away. All right. Either the slab pulls away through deflection, and it pulls some of the slab. They actually have a name to it. 1980s, they called it the slab drop. Either they pull that away, or it comes with it. when it pulls, so either slab pulls away or it pulls away the between each column, there would be that slab drop, and that would change to 1'6" as opposed to 2'6", the original plans. The 1'6" dimensions, if it was 2'6", would have made that whole column area more rigid, right, across the top. And I think I'd divert to looking at, and in one of my videos, think of it as a plinth beam. I know we don't really use plinth beams here in the U.S., but think of it as a plinth beam and giving it that rigidity down there. And the plinth beam between K, L, and M, between L and M, between M and N, sorry guys, K is on the far left. I'm straining my brain here. L is L is the door opening at the garage when you enter it out from outside, from the north side where the lady took the filming. As you look down her camera, look to the right. That door to the right, that's L. As you look to the left with that video, that's M. I'm closing my eyes and visualizing this, sorry, as I speak to you. All right, so that L and M. Now go back out to the pool deck, turn back around. Now face the building. It's reversed. And I made a mistake with that one time in one of my videos. Nobody called me out on it. It was a mistake. It wasn't a troll, because I like trolling sometimes. So to see if you're paying attention. So that would be M to the right and L to the left. That's the driveway. That is also where the step up goes from, where we have to look to the left between K and L. Professor Lehman is 1'6" slab drop. Detail. It was 2'6". If you look back between M and N, it's now not, it wouldn't be a line there. Cars would butt it. So it's actually first 7-inch transition, and then it go over, 7 foot back, and then it's 11 foot back. So, oh yeah, the drawings, I just put that paper down. Shit, I shredded it. I'm happen to be in my, give me 1 second as I talk out loud to you. Bear with me. Bear with me. Nope, I shredded that detail. I was getting aggravated by it. Yeah. I have a desk dedicated to that in this. I've got multiple offices, and I have a desk dedicated to that, and I happen to look up and look to the left, and there's the one dedicated I'd like to show you guys, but dedicated to this crack pottery of this building. And that means my insanity with this building. So you get the elevation change. So the first elevation change is about 7 inches. I still think it's 7 inches, and then it goes to 11 inches in elevation. Not to be confused with the 11 foot wide and 7 foot wide upper and lower decks there, coming out of room 111, condo 111, unit 111. They have the steps also. So that's where we get the deck having a behavior different. If you can look at it as visual X-ray eyes, you would say, oh, look, this deck is really kind of supported out here, and it's supported on columns, but they use an upside down beam now. Yeah, the beam's on top of the deck. The deck comes over, and how's it held between the column L and M? It's across the head to some degree, and then they put with hangers on it, rebar hangers down into the deck across the beam. So it's got some rigidity there, if you will, added rigidity, upside down beam across there, and that's a transition to make that next slab detail, and it becomes elevated. That slab's elevated so the cars can come down and not have headroom. And then it steps back one more time, and then when you get to the building, it's now the internal building is the 13.6. Is that the floor height? And then you minus the thickness of it, and you come down to whatever you do, but you still step down further into the building in the 111 from 111 condo and go back, and now you've got another transition up to, wow, it steps up huge to make it into that the fire room, the utility room with the sprinkler heads and everything. And that's a video where the lady took the from the street. As you face it, you look above, you see the vents. That's the actual where the fire pump room is. All right, and that gives you more headroom again. And you can see the headroom rating outside. That says 6'11", I think, 6 foot 11 inches. And then as soon as you clear that, you've now got even more because the ramp, the driveway goes down, and the headroom goes up on the in the first floor, the lobby floor, if you will. And then it starts drops down. The floor does to the pool deck slab. Good eyes on that one. I have. Okay, moving on. I've never suggested the beams. Okay, all right. I've never stated that the slabs pulled down. Okay. I just noted that the cracks propagated into the region of the tower, which might have resulted in a similar progressive collapse scenario. Loss of the slab wall connection would increase the flexural and deformation demands on the slab column connections. So again, initiation is loss of the slab wall connection. I think your computer program's giving you too much bias on this one. Because we got to get into the building. I believe you're talking about at the building at this point. Loss of the slab wall connection. Correct me if I'm wrong on that. Because you got to get into the building at that point. And so that's your initiating. And I know yeah. And maybe you haven't seen all my videos yet, but I wouldn't recommend you do that. Rather ask me a question, I'll do a reply to you. The vibration the person felt on the machine. So I've gone down the rabbit hole really deep on this vibration. So frequency. Everything, to get vibration, you got to pick up frequency. Let's think of an oil truck going down the street there, and your windows start rattling. People think their building is shaking. It's not the building. The vibration, the frequency created by the truck as it's driving and contacting an engine and air pressure around it creates a frequency and air pressure that is changed as the truck comes down that specific street, and it makes windows pick up the frequency. The air pressure does, and the windows pick up the air pressure, and they then go into a frequency that we hear as a rattle, a rattling noise. But initially, one push on the window doesn't get you a rattle. It's a frequency, a release and pressure again, release and pressure again, release and pressure again. Gets your windows rattling as we know it as. So that's the frame. The frame is not rattling, it's transferring the frequency. The frames or less used frames are rattling, right? Maybe the glass rattles and it moves the frame. But your doors aren't rattling, your bricks aren't rattling. They get the same frequency and they're like, we're not doing anything here. That frequency doesn't do a thing for us. The Windows frequency itself, we'll take that air pressure, turn it into a frequency, and you hear rattling sound. So I looked up trains that are in Chicago and other places that are by buildings. They get frequent rattle, we call it, right? Rattling now. We determine what rattling is. The windows rattling. So the building should be on the ground by now. They've got 100 years of frequency just shaking their buildings apart. And that shows the buildings are not falling apart. And so you're like, okay. So the buildings, people misinterpreting rattling sound for my building is shaking. Your building's not shaking. And then I played around with frequency with tampers and everything else with what I have access to. And I try to pick frequency up on the ground, different things like they do professionally. And air pressure and things like that, and even using glasses of water to see what the frequency would be. And you can do that simply by putting it down and move the glass further away. And you can see when it can pick up the frequency of music, for example, of a speaker. But your glass is sharing the frequency, and the weaker one picks it up. What we see is the weaker one. The one that's in frequency with the music picks it up, and it shows that the floating over the water, if you will, the wavelength. So now we got this guy vibrating down over the ground over there. If you look at the videos of audio images of the placing the products into the ground, the sheet piling, and you can profile it. And I was shadow band, I would do all this extra work. You could profile the amount of time it took to drive one sheet pile, 2 feet, and then the next one, and they take a lunch break even. You could profile this. And you will see that you should be able to see cracking. Since you made it to the building, you should be able to see cracking, the pool shaking, things like that. Nothing was reported about the water even picking up frequency as they were vibrating. But before that, you look at the driving of the sheet piles, and you can see mounds of sand right by the sheet piling. And as the sheet piling is going in, it's not even consolidating. Angle of repose of that sand is so darn stiff. It's amazing. Of course, it's not stiff, but it's not stiff as in with water holding it together. It looks pretty granular, and yet that's not filling in around a sheet piling. It's not backfilling. You'll see a concave area there. I'm like, well, that shouldn't concave if there was a high frequency there. So, debunking the frequency thing, I go back to finding that someone dove deep into this. It's an old report. They were moving they had a chance to do this test. They were moving putting in sheet piles by a historical building, and they really wanted to see if they could protect the building and also use it as an example. So they loaded this thing up, this historical building, and with ground sensors. They loaded it up and they ran the sheet piling, and nothing. And they were very close. We're talking 6 feet to the building, nothing. And the sheet piling force was excessive of what they did in the sand down there. They were doing it up in the area with a much higher consolidated material density, if you will. And so you would then have to get the vibration to go from the sheet piling they're driving over 10 feet and then the sheet piling again at the CTS. That sheet piling would have to pick up the frequency that it just left the sand from, because it's not, you're going to have some air pressure, but it's not enough, right? So we're going to discount the air doing it, vibrating windows. So you're going over, it has to now pick up the frequency, the metal does, because it's intercepting it. It then has to share that frequency it picked up, whatever it may be, into the concrete that's composed of tile, sandbed, slate. Oh, I'm sorry, it's not slate, whatever the tile are. Go across the deck, including the columns intercepting it. They're acting as dampeners, if you will. Go across the deck, go across the planter box area, dampeners again, and then hit the other steps, transition up the steps into the, through the steps and or through the drop slab detail. That frequency would have to pick up, and then it would then have to pick up the floor frequency. Floor frequency has a wall on it. And then it would have to pick up the floor frequency over to this person that was doing bicycling. I'm sorry. He was doing, being facetious, doing treadmilling. The treadmiller then is on a treadmill which has its own frequency. And he said he fell off. He was on a moving frequency machine. And then he fell off and then blamed the vibration over there. I think he fell off, got up, and screamed that they, in his mind, that they did that. You ever hit your finger when somebody's talking to you? You want to blame the other person. That's the amygdala. I'm real deep into the psychology. So the amygdala is angry and it wants to attack. It doesn't care that you just hit your own finger. It wants to attack, and then now your opportunity presents. I get to scream at you because you distracted me. In reality, you probably didn't distract me. I'm destined to hit that finger. Maybe you did distract me, but you ever stump your toe and then no one's around and you still throw something or hit something? That's the amygdala reaction in anger, it wants to fight. That person probably fell down, simple as that, and then blaming the people over there once he heard the noises. They caused me to fall down. The frequency would have to be so great, it would have to pick up a moving treadmill's frequency and then supersede that and and then into the pad, into the bearing rollers, into the rubber pad, and then throw this guy off. It's just ridiculous. All right, so that's that one for you. So I don't get into that building there that way, and I can't get into it without damaging being presented to us your way. But let's go from there. Loss of the slab wall connection would, right. I postulated for the pool deck. Okay, wait a minute. which follows the progression collapse scenario I postulated for the pool deck. Okay. Loss of the longer continuous slab wall connection results in less slab wall. We're not talking about the south wall, are we, or are we? I think we are at this point. In that case, I'll reverse that over here and we just talk about the vibration again, right? I don't have it there. And Professor Lehman, I do a video and I talk about cantilever and stiffness and I talk about how how you can even get the spalling. We're going to refer to it as spalling, right? But it's what's left behind. The evidence that's left behind. It's a fingerprint of what's left behind after you rip rebar out of that wall. And when I say wall, I really mean floor, because the wall and floor was engaged together with rebar that came up from the floor. And what's part of what we see is part of the top of the wall, and then we see part of the floor. So it's, it's kind of composite to the wall floor system. And when it broke away, and I give no value to anchoring from the wall system down into the pad, the pool deck pad. They only use 6-inch, back to 6 inches again, epoxy dowels every now and then, and you can you can still identify them. And I think there's only one that was bent. Underneath one of the columns. I postulate the deck. Loss of the longer continuous slab wall connection results in loss in stiffness and strength and increase in the force and deformation demands on the slab column connections. Well, I agree with that. But I do it through deflection. I have the butterfly area, I call it, if you're not familiar with it, I guess I'll have to show it to you, but the butterfly area gets the deflection, which I have two forms of punching shear around the columns. And one is, if the critical shear zone is in place, you'll get a punching shear that leaves a capital look, a capital head, if you will. It's not really technically a capital, but so viewers can understand me. Capitals would be underneath. This is just the what's remaining is what I'm referring to in this one. This is a plate slab system, so it will not have a capital. But that's what so you have a capital meaning the top of it. Okay, how about that? The capital, it would be left if the critical shear zone is more rigid than the pad, than the tributary areas. But if you see it pull down, lack of tact, people can learn, it pulls over just like a condom over the head of it. And this helps people learn too, because I'm calling the head too, the head of the columns. Then it shows you didn't have a large strong critical shear area. Interesting, you capture more reinforcement. You stated here with your stiffness of what I call the strong backs of the planer boxes. I do that also in just a recent video I posted, saying that if you look at the pool deck, now go over there and look at the pool deck at the pool area after the fact, and you'll see that the slabs are capable they have quite a cantilever on them. They had quite a rigidity to them. Now, I want you to think of that's all over top of each one of those. Now, it was not composite. It wasn't drilled down into the subsurface slab. It was placed on top of. But if looking at that and now doing some extrapolations, you can see it looks like it can hold about 6-7 feet of cantilever. That's pretty rigid. Now, put that on top of the pool deck, on top of the columns, and not the one you can wrap around by the cars. That's going to behave differently. But on top of the columns, and you extend that rigidity out 6 feet, square, if you will, around each one of the columns, and just use 6 feet, just based off of how the behavior of that one by the pool deck is. And it probably can do better because that was ripped out, remember, torn down? So it was quite violent. I wonder how much rigidity that concrete slab could really do. How much did it really save and act as a wear layer, strong back, and not a problem in the primary pool deck area? And then in the car area, now it wraps around the columns because they don't have the luxury of going across the column heads because they can't. It's a different concrete behavior over there. The interactions, and they didn't anchor it to the columns, that slab. I mean, who would have thought of that, right? So that behavior there then becomes more like a dead load over there. It becomes more like a dead load, whereas the pool deck area, it's got that rigidity. Again, look at and we can talk on the phone. Look at the rigidity of the extension from the pool deck. All right, let's move on. Okay, providing links. Miami Herald, peer review. All right, and we just finished a 10 specimen series of slab column connections tests that are possible rehabilitation scheme for deterioration flats. Well, I would love to have seen that. This one for plates. Oh, hell, you're getting me excited here. This last part. Oh, I definitely would love to engage in that. And all right, so for my what do you call it? Olive branch. I'll go back. So anybody who's seeing this, I'll go back and I'm going to make private or delete or throw them in the private room only. Anything I might decide is negative towards Dawn Lehman, Professor Lehman, because of this response here. I tell you guys, I'm not one to change my position. I mean, not one to not change my position. And this person engaged. And as I told you guys, I often do videos to troll people out to communicate. This video, by chance, just happened to get Dawn Lehman to reply. And with that said, those videos are gone. They'll be, I'll go back in there and suppress them. Short of this one, I'll have to go through it. Or I'll speak with Dawn Lehman on our position, what would she like me to do for fairness. All right, talk to you guys. Love you, bye. And this is a reaction video, a reply video rather. And let's go from here.